So we are looking at solving systems of equations involving quadratics, and we're going to solve this linear quadratic system. So here we have our quadratic expression. Okay, this is x squared plus y squared equals 25. So this is a circle with radius 5, and this is our linear equation, slope 2, y-intercept of -2, going through like this. And this is going to have two intersection points. Okay. So our strategies for solving this could be, well, we could graph this on our graphing tools and check out the intersection points. We can also solve these algebraically. So this is what we're going to focus on, and our algebraic strategies are: 1, we can do substitution; 2, we can do addition, subtraction. So this one lends itself to substitution the way it's set up. So I can see that it's already y equals down here. So I can substitute for this y. So I'll set it up this way. So I have x squared plus y squared equals 25. The y is going to be replaced by the equivalent 2x minus 2. So I've made this system from a 2-variable system into a 1-variable system. Okay, so I now have one equation, one variable. I can solve this as a quadratic equation. So if I expand these brackets, I end up with 4x squared minus 8x plus 4 equals 25. Okay, so the quadratic equation, grouping my terms together, 5x squared minus 8x, and this works out to be minus 21. And that's equal to 0. So solving this quadratic equation, it looks like I might be able to factor this. Let's see here. We have 5x squared negative 21. So this is going to be 105. Two numbers that multiply to 105 and have a difference of 8. Looks like we can use 7 times 15, it looks like. Okay, so 7x and minus 15x. Okay, so that's going to give us our factored form. So we can factor 5x out of here. Looks like we're going to go plus 7 here, x minus 3 here. Okay, so factoring this, we end up with x minus 3 times 5x plus 7 equals 0. So our values for x equals 3. That's our first x, and x equals, looks like negative 7 over 5. Okay, so then solving for the y value, I can just plug it into my y equation. So if I plug it into y, I get y equals 2 times 3 minus 2. So this works out to be y equals 4. Okay, so that represents one coordinate, x equals 3, y equals 4. And then I'd have another intersection point here. I'm going to substitute my x into the equation. Negative 7 over 5 minus 2. So I'm substituting into this y equation, working this out. This is negative 14 over 5 minus 10 over 5. So it looks like I get negative 24 over 5. Okay, that looks like it's about negative 4.8. So at x equals, this coordinate here would be negative 7 over 5. And the y coordinate is negative 24 over 5. Okay, so just clean that up a bit. So that's going to be negative 7 over 5. So we have the solution to this linear quadratic system is going to be these 2 points. And we did this by substitution, solving the quadratic. Okay, again, make sure you solve for both the x and y coordinate because this is a system. So we need both the x and y solution.